Assalamualaikum and salam sejahtera. My name is Nurat Nasari binti Bahar. Matrix number B0220100097. Today I would like to present about the lab 3, which is the voltage regulator. The objective for this circuit is this lab is to study the characteristic of a simple series voltage regulator, improve a series regulator using OM and basic shunt regulator. And then we start with the first circuit, which is the OM series regulator. We run first this value for this circuit. Multimeter. The second multimeter is display the output, which is 6.95 watt, and then the first multimeter display the V reference at the Zener diode, which is 5.073. And then then the transistor Q1 is the series control element, and the Zener diode DZ is a provide the reference voltage. And then we have OM is a comparator circuit, which is the for series voltage regulator. The BJT was in series with the input, which is used the series with input with the input for the circuit is 7 watt, and then the output is the 6.5954 connect with series with the Q1, which is transistor. Okay, when the output voltage is increased, when the output voltage is decreased, it will increase the base emitter voltage or VBE, and will causes the Q1 conduct more current and rising the output voltage to maintain the output voltage output constant. And then the second situation, when the output voltage is increased, which the first one decrease, and then the second one is the increase. This causes the decrease base emitter voltage or VBE will causes transistor Q1 to conduct less, reducing the output voltage, which is the maintain the output voltage. And then we start run first, and then we go to the second circuit, which is the shunt regulator. For the shunt regulator, we set up we calculate same with the first circuit. We calculate the either one R2 or R3. We calculate another one, the resistor we assume, which is for this circuit we assume R3. The value of R3 we assume, then we calculate the R2 with the voltage output was given. So for the shunt regulator, the shunt regulator same with the series regulator, but for the shunt regulator we added with the RS for this shunt regulator. Okay, for this shunt regulator, voltage regulator, we using the OM same with the first circuit. The Zener voltage is compared. The Zener diode is compared to the feedback voltage obtained from voltage divider R2 and R3 to provide the control driver current to shunt Q1. And then the current flow to the resistor Rs or for this circuit R4. Thus, the control to drop the voltage across Rs, and then so that the output voltage is maintained, which is the input we use input 10. Then using the Rs is control drop voltage across Rs to maintain the output voltage for this circuit, which is 9.982, approximately to 10 volt lah. Okay. Okay. So this is sorry. And then for the last circuit, which is the uh, for the third circuit, which is we using the IC. The IC what we use is LM317AH. Okay, for this IC we use this IC. Each IC have a different range of the current and the voltage input and output. So for this IC, we have a current 1.5 ampere. Then the range of the voltage, which is V out 12 to 37 volt. The IC, this value of V out and current for this IC we can see at the database, based on database for this IC. And then for this circuit also, this voltage regulator is especially easy to use and require only two external resistor to set the output voltage, which is we have R2 and R1. For this circuit, we assume R2, which the R2 is a voltage variable, a potential variable, resistor, variable resistor, which is we use a 6 kilo ohm. The value for we can for this you can adjust which is okay. And then the with where R2 we assume, then after we assume the R2, we can get R1 using the formula V naught equal to 1 plus R1 divided by R2 times with VS, VZ lah. And okay, for this plus with the adjustment, and then we can get the value for the output voltage, which is 11.55 volt. Okay, only for that. Thank you.